In two-dimensional geometry, we saw how to find the coordinates of a point that divides a line segment in a given ratio. In this module, we will explore how the coordinates of a point that divides a line segment in space are found. Let AB be a line segment in space. We have another point C on AB, which divides the line segment into two parts in the ratio m:n. We will find the coordinates of point C that divides line segment AB. Let the coordinates of point A be x1, y1, z1, and point B be x2, y2, z2. Let the coordinates of point C be x, y, z. We draw perpendiculars from points A, B, and C onto the xy plane. Let the feet of the perpendiculars from points A, C, and B on the xy plane be P, R, and Q respectively. Lines AP, CR, and BQ are parallel to each other. The line joining points P, R, and Q lies on the xy plane. Now, we draw a line parallel to the line PQ and passing through point C. This line intersects line PA externally. Let the point of intersection be D. Let the point of intersection of this line with BQ be E. We can observe that quadrilaterals DPRC and CRQE are parallelograms since lines AP, CR, and EQ are parallel to each other, and lines DC parallel to PR and CE parallel to RQ are also parallel to each other. Since AD and BE are parallel to each other, in triangles ADC and BEC we have. This implies that triangles ADC and BEC are similar. Therefore, this relation holds true for the triangles. From the figure, we can observe that the left-hand side of this relation is equal to m divided by n. On the right-hand side, we can observe that dA is equal to dP minus AP, and BE is equal to BQ minus EQ. Since DPRC and CRQE are parallelograms, we can observe that DP and EQ are both equal to CR. Substituting the values, we get the relation as shown. Therefore, the z-coordinate of point C that divides line segment AB in the ratio m:n is as shown. Similarly, using the same method, the other coordinates x and y of point C can be found. Therefore, the coordinates of the point that divides the line segment in the ratio m:n is as shown. Now, we will see some special cases of the section formula. Again, let's consider line segment AB in space. If point C divides AB exactly into two parts, then C is dividing AB in the ratio 1:1. Therefore, m:n is equal to 1:1. This implies that we can consider point C as the midpoint of AB. Substituting in the standard formula, we get this. Therefore, the midpoint of a line segment is as shown. If point C divides the line segment in the ratio 1:k, we get this. The coordinates of the point that divides a line segment in the ratio 1:k is as shown.